Hello, and in today's STM32 programming, we are going to be covering the serial UART with interrupts. Now over here I have the configuration. The parameter settings won't change in this tutorial. So simply what we do is we go to the nested vector interrupt controller, so the NVIC settings, and simply all we do is we click enable global interrupt. Now this will enable the global interrupt for the UART. Then we just have a double check at the nested vector interrupt controller section just to check if our interrupt is actually enabled. And it seems to be enabled with our check mark here. And then we can see the preemption and sub priority on the side over here, so you can adjust your interrupt priority. For this series, most of the interrupts will be at priority 0 along with sub priority and the default for the system time ticker at 15. Okay, so now we can just simply click save to generate our code. Okay, so now our code is generated. Now we can have a look at the useart.c file and see what has changed there. So nothing for the UART init. So this file hasn't changed whatsoever. So now we can separate our UART.whole file, and then we can go to our .cpp file for the creation. So this will be a child class of the base class. So what we do is we start with class, and it's going to be called UART-IT for interrupt. And that is going to inherit the base class, when I can one day spell public correctly, and the UART base, and then we can simply copy the constructor and destructor from the base class and just change the name. It's going to be in the public namespace, and then we are going to have some private variables here. Okay, so the first thing we want to do is we want to build the constructor for the UART interrupt. So we just create it here, copy the parameter list, and that will instantiate the base class with the following parameters inserted. Okay, so we need to do some modifications to the project to enable us to use C++ properly with the UART. So what we're going to do is we're going to go to core, we're going to go to includes, and then we are going to go to, I believe, the whole config. Yes, it is the whole config. And we just scroll down, and then we can see use whole UART register callbacks. What we want to do is we want to set that to 1, and I will explain in a bit why we have to set that to 1. Then we, in our constructor, we say if the UART whole register is not equals to 1, and then we end our preprocessor if. Now we can have a look at the UART type def. And you can see in the UART type def, this UART callback, if you want to just look at it here. Here it is. So this macro enables these block of callbacks. And these callbacks are used in a variation of the functions in the C files in the UART. So this enables us to point to a specific function that does the UART callback. We can see here the two we are interested in is the txcomplete callback and then the rxcomplete callback. So they are defined as these two functions. So what we do is we take them over here and we just store them here for now. And here we have to print out an error that I've pre-prepared for this. So this will be our compile time error. So if we compile this with the callback set to 0 and we build, you can see here is our error message. So at compile time, it checks if the macro is set or not. Otherwise, we are going to get compilation errors anyways. So now we have to modify the UART whole type def, and that will be a pointer to the txcomplete callback, and we'll just set it equal to null for now. We do not have the functions yet to point to this in the rxcomplete callback. And actually, I want to change this function. We just set that back to 1. And I want the UART event callback instead of the receive callback. And the UART event callback is of UART and position. Now we need to declare these two functions, and we'll just call them as private functions, and these will be static. So across all the object instantiations of the UART interrupt, and it will be static. Both will be void. Now we need to look at what the parameters are again. So this will be, for the TX complete, it will be the UART whole, which we can have here, and the event callback is going to be also UART whole with a parameter of pos. Then what we need to do is we need to create a protected variable, and then we're going to say bool and is tx done, and by default tx done will be equals to false when it is initialized. Now we need to declare these two static functions. So very simple, we just copy them, paste, and then with the next one, paste it, and then we give it a namespace for the interrupt. Okay. So now we have our callbacks linked. So we have private functions governing our UART interrupt. Now we need from one of our previous tutorials, we need a ISR list. So we create a object as a protected variable, ISR, and that will be of type UART IT, so UART interrupt, and this will be the ISR underscore list. And the ISR list will be a dot add, and we want to add this object to the list of the ISR. Okay, and then we need to set our callbacks to the functions we want to call. So this is going to be our RX and event complete, and they are going to be of namespace UART interrupt. Let's just check for a compile here. Does not name a type. Okay, we need to include our ISR underscore list, ISR whole.h. Just quickly give that a build. Must be set to 1. Okay. Okay, it should be useArt set to 1 or not. Let me just double check this. Okay, so it's this one that has to be set to 1. And then in our whole, it must be set to 1. And then we build. Okay, so we have a successful build. Now in our destructor, we simply just need to add the namespace to it. It's going to be void and void. And in our destructor, we need to remove the ISR when we go out of scope. So this is the ISR list remove, and we remove this from the ISR list. Now we can finally get to the read and write functions. So we can actually just simply copy these functions over, remove the timeout. So we are overloading the read and write from the base class with a different parameter set. And then we're going to add an additional function, and we're going to say star read for that one. So where do these functions come from? The UART whole.h file. We check the outline of this file. We can see somewhere here there's functions. We can just quickly jump to a set of functions. We can see here the UART transmit receive, UART interrupt receive. We can also see the DMA. And then we have 3 other functions here, which is UARTX receive to idle, and then receive to idle interrupt, as well as the DMA one. We'll be covering the DMA at a later stage. But effectively what this function does is it waits for your UART line to become idle before triggering the interrupt. So you have 2 conditions where your interrupt triggers. Your buffer is full for the number of bytes you want to read, which is the size, or the UART line has gone idle, meaning it's no longer receiving data. So you get a interrupt event on that as well. So for the interrupt, how you start a read is you simply just call start read. You simply call this function, and then you have to sit and wait until the interrupt triggers to get your data back. So this is why we have the start read and then a write as well. So for functionality, we are going to start with the write function, and we are going to say in the write function, we are going to copy the UART transmit it function. So we copy that and just simply paste it in here. Then we read return the UART whole transmit. That takes in our protected private variable from the UART base class. And simply the data we want to transmit, which is going to be p data, and then the size of the data that we want to transmit. And then for the interrupt, we need to check if the UART, if the TX is complete before we can call another write function. We say if not TX. So if TX is false, we return whole underscore, I believe it's busy. Yes, it's busy. And then we set tx done equals to false. And then we need to set the tx done to, actually we need to instantiate this as true. If tx is not done, we return is tx done. And then we need to have an indicator of when the tx callback has completed. So I've pre-prepared a for loop here. Because we can have multiple instances of the UART, we simply just iterate through all the ISRs that we can possibly have in the UART. And we also need to declare the UART ISR list because it should be a static object that is shared between all the UART interrupt objects. So we just declare it here as our static variable so our C file can see it. Our CPP file can see it, source, whatever you want to call it. So we simply just iterate through all the instances that have been created of the UART interrupt. We first check if the current instance that we get from the callback is the instance in this ISR list. And if it's that instance, we set tx done to true. And then we just give that a quick compile. We have a lot of errors. Let's make that identical in our header and source file. See the errors it gives us now. Not declared in this. Oh, I need to add the namespace operator to this. Okay. Now for the start read, we are first going to create a instance of read. Just for curiosity's sake, can I make this read private? And then we also create a start read, just so that we have the prototypes. Let's see, warning, no return statement, no return statement. Okay, great stuff. Okay, so we're back to our UART whole. We want to do a UART receive to idle interrupt. So we just copy this function again, and we are going to wrap this in our CPP file. That's going to be our protected variable from the base class. We pass it in the data and we pass it in the size, and our read is going to return our whole error. Actually, this should move up, and then we simply just call read in our function, and that's going to be p data and size. And then we just quickly build just to check that everything works. No return statement in function. Actually, we need to return here as well. And then we build again. Okay, great stuff. So we have built no reading functionality yet in, but first we're going to check if we can do the write of the interrupt. So we go to our main.cpp, and then we can simply just comment this out and call this UART it. That's going to be UART1. And here what we do is we say we are not going to start the read yet. And then we just repeatedly want to create a write. And we say 64. And we set the 64 bytes equals to a string of, let's say, program start. And now we are going to repeatedly write that same string to the console. Let's just add a \n\r for our returns. We build, everything seems okay. We flash, and apparently nothing happens. Let's just give it a debug session because it's running in the main.c file. Excellent. Okay, we just need to open our project. We open the C. We delete main.c. Delete our debug, compile again, and flash our code. Apparently nothing's outputting on PuTTY, but if you can look at the camera, you can see the stop LED, this one over here, is indicating that it is actually receiving something. It seems to be possibly too fast, so let's try slowing it down. So we say whole underscore D, or possibly I have too few lines here. Ah, there it is. There it is. I had too few lines. So you can see program start flashing there. Now we know we can send data. If I change the string, so it's just going to be some random characters now. I'm just going to flash that onto the chip itself. You can see the receive LED is off, and it's on again, and now you can see a different string on the screen. And when we go back to our main, you can see the string that we changed here. Okay, now back to our C file. So now we're going to work on the receiving code. So the receiving code is going to use the start read, but for the start read, I do not want any parameters. So what we do is we need to create a buffer in here. So that's going to uint8 underscore t. Actually, I have a different purpose for this read, but we are going to change that. Let's move that over there. And then we say read is, we're going to make that an integer. And that's also an int. We make it void. And our p data is going to be a uint8 underscore t, and we are going to call that the read buffer, and we need to give that a size, and we can do that with a macro. So we say define rx underscore size buffer, and then control shift y, actually control shift x, and we say 64 bytes. We can receive 64 bytes in the rx buffer, and then we give that the size over there. Okay, so our p data is going to be this rx buffer. The size of the rx buffer is going to be size of rx buffer, and now we need some way to save the data that we get back from the Rx event callback. What we're going to do is I'm going to implement a circular buffer template. So we create a new header file called circularbuffer.h. We finish. And the circular buffer is going to include two files, and that's going to be main.h. And the second file is going to be include, and that's going to be string.h. And this is going to be a template of a class of type T. Now we can create our class, and we call it circular buffer, and that's going to contain a public space and a private space. And then I'm going to copy some variables from pre-prepared code. Our template is going to be a pointer to a buffer, the current size of the buffer, the in position of the buffer, the out position of the buffer, and how many objects of type T is stored. So we create our constructor. So the constructor is going to take a parameter of size. This will set the size of the circular buffer. The impos, outpos, and the stored is all set to 0. Then we allocate a new block of memory of type T of the size, and then we set the buffer to 0. Technically, you shouldn't be doing this. The constructor of T should be handling this, but I'm going to keep it for like this for now because it's actually intended to be used with primitives. And then when we destruct, we need to deallocate the buffer. So we simply just delete that, and we're going to add another function, which is going to be put. So void put takes in a pointer to the data of type T and then the number of objects of T, and that simply just adds the number of objects to the buffer, increments the impos, increments the stored variable. When the impos size is greater or equal to the size of the buffer, reset the buffer and start from position 0 again, and we set the store value equal to the size of the buffer if it starts overrunning, so that the buffer indicates that it is full. And then we have a next function which is going to be pull, which we are going to be using to pull data out of the circular buffer. So it also takes in a parameter of a pointer of object T and the number of the objects that come in, so the size of the objects. The read size is what we are going to return, so the number of objects we have read, because we can only read so many objects when we pass in the size. So we loop through and we start pulling data out. So if the stored data is 0, we break and then we return the number of objects. We take our data in, then we copy over the data from the circular buffer, and then we increment the pos, then we deduct the stored value. So if it is 0, we break, otherwise we deduct 1 object. And then if the out pos is greater or equals to the size, then we just return to the starting point of the buffer. And then for every object that we read from the internal buffer, we increment the read size. And then we implement a very simple function, which is stored, which just returns the number of stored items. And then finally, we have our last function of the circular buffer, which is flush, which basically just resets the entire circular buffer to its initial state. So it clears out the buffer. Okay, now that's a mouthful. So we need a circular buffer in here, along with our reading buffer, and that's going to be a uint8, and that's going to be *_buff. And we need to include our circular buffer, so hash include circular buffer.h. So now we have our circular buffer in our UART code, so we can go back to that. We just quickly build, see if we have any issues. We just have a warning over here. The warning doesn't really matter. And we have start read. Then for our read, we are going to say our buffer. We actually return our buffer. We say pull, and that's going to be pdata and then the size. Let me just check what the data type is for pull again. Pull is a uint16, so this should return a uint16 and not a integer. And we move this to the public space. So now we have a method to pull our data out of the next thing is we need to put the data into the circular buffer via the receive. And actually when we say start read, we need to clear our RX data. Actually we need to put this here and our read buffer. And that clears it out. Okay, so now we need to place the data into the circular buffer. And that will be a private function underneath the static functions, and that will be a void, and then we just call that put, and put will take in a parameter of uint16_t, and that will be the index and then the size. So another uint16 and size. Now we need to create this function. So we simply just copy this over along with its namespace. And then we can take our UART buffer, well, circular buffer, and say put. We take our read buffer and we set that equals to the reference to the index. And this is the number of bytes we have received. And then finally, we need to call a start read again. Now, what happens with a interrupt, as soon as it's triggered, you need to restart the interrupt manually for the UART. So every time this interrupt triggers, you need to restart it to receive to idle. So first you extract your data and then you start the interrupt again. And then simply what we can do is we can go up here and then we can copy our iterator through our ISR list. And now instead of doing the UART done, let me just see here. Now instead of the TX is done, now we just call the put function, and the put function will take in an index always of 0. We're actually using the put function for future proofing for DMA, but we'll get to that into the next video. And then we pass in the pos, which is the current position, which is the ending position of the buffer. Because if you can look at the UART whole type def, just scroll here, there is a pointer here to the UART RX transfer buffer. So this will contain your data and you give it a reference to this. And then the xfer size, which is the RX transfer count. This tells you how many bytes have been received by the UART during an interrupt. DMA works a little bit different, but we'll get to that. Now we have our put function and we have our read function, some way to pull out the data. And then we just quickly build this. See, everything seems to be fine. Okay, then we go to our main.cpp, and then simply in here we say our UART1, we start our reads. So we initiate the reading. So we have automated read, and we say if, then we call our UART.read function, and we give it our C buffer, so our incoming buffer, and then the size of C. So whatever we read, then if we have read something, let's just make deathly sure here, is greater than 0, then we write whatever's in C, and we write for the size of C. Actually, we say uint 16 len is equals to, so if the len is greater, then we write the number of for len, and we just need to add a comma point there. Great stuff. And then at the end we do a mem set for C, set everything to 0, size of C. And we just clear it out here because we're not going to be using the string. So very simple. When we read, if there's something in there, we return the amount of data we have read. If it's greater than 0, then we simply write out the data that is in C for the length that we have read. Let's just quickly build that, see if it works. It's fine with the build. Let's have a look at the board. Okay, now as I type, it hicks. So let me just refresh that again. Okay, hang on while I debug this. I have an idea why the UART is hicking. I'm writing and I have a shared resource with this. So technically I should wait here until the write is done. So we're going to make this somewhat blocking. We're going to create a final function that's going to return a bool, and it's going to be is tx underscore done, and it's going to be a void parameter. We say that returns the isTxDone bool. So we can just simply say while UART1.isTxDone, actually while tx is not done, then we block that we can't write to the UART. So let's see if that helps the code. I should probably add a namespace there if I'm guessing. Yes, that's exactly what I did wrong. Okay, build that, flash it. Now let's see if the UART works. And it's still hicking. So I pulled a complete dumbass on myself. What we need to do is, we actually need to give it the circular buffer to valid memory space. So buffer is equals to new, and we say of type circular buffer, and we pass it in the, let's see, the size of the running buffer, and just to be safe we times that with 2, and in our destructor we delete the buffer. Technically I should be wrapping this in a, let me do it. If buffer not equals null, then we delete the buffer, and let's see if that gives us a improvement. So quickly flash the chip. And there is it solved. We have a circular buffer with interrupts. Okay, so this is a basic introduction to an STM32 with C++ using the interrupt on the UART. Like, share, comment and subscribe is always appreciated. Thank you. Have a nice day.